So this TEST-12B, class 9 science. Okay, chapter 12, starting with question 1, go to page 180. Let me read the question for us. Question number 1. Okay, look there into your textbook. An echo returned in 3 seconds. What is the distance of the cliff, reflecting surface from the source, means source of sound, given that the speed of sound is 342 meters per second. So let's go slow here. So here, as we read the question, t, which is 3 seconds, is the time taken. You can just, for echo to return time, according to the language of the text, taken for echo to return, means to return to the source of the sound. Okay. Now S, this is question mark, this is the distance, okay, traveled by echo. This is not a, kindly note this one clearly, traveled by the echo. Okay, later on we'll discuss. This is not the distance between the source and the reflecting surface. This is the actual distance traveled by the sound from the source, and after reflecting from the surface, coming back to the source again. That is this S. Okay, this is not what the question is asking, but we need this, so we're writing V is equal to 342 meter per second is the speed of the sound. Just write like that. Now the basic formula for speed, we all know this, which is very easy, so just write it in the basic form. Speed is equal to, we know, distance divided by time. Since we are interested in finding the distance between the reflecting surface and the source, let us find the answer first in terms of distance. So don't move the numerator. If you shift this denominator, it will go up to the numerator and multiply the speed, so time will go up, this time. After that, we can transfer it to speed. Here we have taken V, time we have taken a small t in our question, and distance we have taken as distance traveled by the echo as S. So once we get that we can just replace the values, that's all, 342 meter per second. And then like, yes, so this is meter per second, this second minus 1, if you bring down the denominator, it becomes second to the power plus 1, right? But in case of plus 1 power, we don't write, so we just remove it, and then into time is here 3 seconds, so that is equal to as distance traveled by the echo. So that way we can cancel this second and second up and down, and 3 2s are 6, right? 3 2s are 6. We have to start from here, right corners. 3 2s are 6, 4s are 12, 1 in hand, 3 3s are 9 plus 1 10, so 1026 meter is equal to S, which is the actual distance covered by the echo. Okay, now here we have to write something now, since according to question, in 3 seconds, okay, sound, echo, or the sound has to travel twice. Every echo has to travel, because echo is the sound that has reflected back, so echo has to travel reflected back. That's why it is twice, because it is echo. Twice the distance between the reflecting surface and the source. The reflecting surface and the source, that means the place from where the sound is coming out. Because of this reason, therefore, or therefore distance, according to the language of the text question, distance between what is the distance between the reflecting surface from the source? Okay, distance of the reflecting surface, like the textbook language, then distance of the reflecting surface from the source. So just think for a moment, it's quite easy. From the source, the actual distance between the reflecting surface. So suppose that wall is the reflecting surface and the sound come out of something like your mouth. So sound go and heat that is reflected back and come to you is called echo. So that is double the distance between the source and the wall, the reflecting surface. So the distance between the source, between the reflecting surface and the source will be the distance of the echo. Echo is twice, right? Go and come is called echo. So actual distance between the two objects, the reflecting surface and the source, will be distance traveled by the echo s divided by 2. Right, so echo is twice, so this actual distance will be echo divided by 2. Echo, distance traveled by echo, which is here 1026 divided by 2 meter. So here, as you can see, s, so 2 ones are 2, 5s are 10, 1s are 2, 2 3s are 6, so 513 meter is the distance that we need to calculate. So that's your answer. Okay, question number 2 is, sorry, example 12.3. Let us see which page number. 12.3, page 183. Okay, let me read the question. A ship sends out ultrasound that returns from the seabed. So from the ship, sound is sent to the surface of the floor, that means the floor of the sea. Seabed means the floor of the sea, and is detected after 3.42 seconds. If the speed of the ultrasound through the seawater is 1531 meter per second, what is the distance of the seabed from the ship? This is very exactly the same type as we've done just now. So t is equal to now 3.42 seconds. That's what we need to change the numbers only. Otherwise, the same type of question we're going to set. This is the time. Okay, time taken for the sonar pulse. No, sorry, time between transmission and detection. Time, according to the language of the text, time between transmission of the sound, means beginning of the sound, and detection. So this is actually the time taken for the echo to travel. Okay, s is the distance traveled by the echo. That will be same. So from the ship, sound is sent by a sonar, sent out by ultrasound to the floor. So the floor is now like the reflecting surface in our previous question. Come back, so that is the echo. Then speed of the ultrasound here is 1531 meter per second. So this is the 15 speed of the type of sound. Here is the ultrasound. Everything will be identical. So we'll write up to here same, and here v, t, s. From here we'll solve. So please write it down up to here. Okay, so here v in this case is 1531 meter per textbook. Like this also okay, or textbook in this case is like this. Same thing, only meter per second, and the time is 342.2 second is equal to s. So s and s cancelled. So 3.42, sorry, 3.42 seconds. So here this two number has to be multiplied. So let us multiply 1531 multiplied to 3.42 2 ones are 2, 6, 2 5s are 10, 2 ones are 2, 3, 4 ones are 4, 4 3s are 12, 21, 4 ones are 4, 5, 6. One more number. So here 3 ones are 3, 3 3s are 9, 15, 3 ones are 3 plus 1 4, so 2, 10, 6, 6 here, and then 13, 1 in hand, 12, 5, so 1 2 decimal places. So this will come out as 5236.02. 5236.02. This much meter will be the distance traveled by the echo S. So here, okay, just write down now, same type of numerical only, so we'll go by the same style. So since, according to the question, in 3.42 seconds, okay, the ultrasound has to travel, or the echo, the ultrasound or echo has to travel, okay, has to travel twice the distance. I won't be explaining because I've explained the first one properly, right? Between the ship and the seabed, distance between the ship and the seabed, that means the floor of the sea. Because of this, therefore, distance of the seabed from the what is the distance of the seabed from the ship? So actual distance of the seabed from the ship will be just like with the previous numerical, distance traveled by the ultrasound, that is echo, divided by 2. So 5236.02 divided by 2 meter, this much. So one cancellation, 2 ones are 2, 2s are 4. Okay, so 2 2s are 4. If you were to go in this one, 2 2s are 4, 1 and then 2 6s are 12, 1s are 2, 2 8s are 16, 2 zeros are 2. So the answer would come out as 618.01 meter is the actual distance between the seabed and the ship. So that will be 2618. So 2618, sorry, here, see, I missed out here, 2, so like this, or sometimes they ask in kilometer. So in such a case, we are now familiar with the conversion units for the length, right, which is kilometer, hectometer, decameter, meter, decimeter, centimeter, and millimeter. So here we want to change, suppose to meter to kilometer, this meter, then you're changing 1 2 3, small to big, so 2618.01 and 1 here, 1 2 3, so each place is 1 0, so 2 3, then kilometer will come in. So this 30 divided by 30 means decimal move 3 places to the left between 2 and 6, so 2.61801 kilometer, which is approximately 2.6. Third place is 5 or more than 5, then second place will increase by 1, so 1 will become 2. So your answer in kilometer is this, or in meter. Okay, then next question, the same, I think, similar type, again, if I'm not wrong, question number 1, page 184. Okay, go there. So let's do that sum. Read the question for us. The submarine emits a sonar pulse. There is sound only, which returns from an underwater cliff in 1.02 seconds. So here, as we read the question, t is 1.02 seconds. Time taken, I think basically this is the time taken for echo to travel. Everything is echo. Once it reflects and comes back, that is called echo. Right, so next, if the speed of the sound, okay, so speed is v 1531 meter per second, 1531 meter per second, the speed of the sound in salt water, that means the seawater. Then we have to find the actual distance traveled by echo first. So S is this one, distance traveled by the echo. Okay, then we know, since basic formula for speed, we can start with that. Is equal to distance by time. So we want to find distance, so don't move the distance on the numerator, then this will become speed into time. Speed into time. Then here next will be speed we have taken as v and time is t, and distance traveled by echo is s. So since 1531 meter per second the speed here, time is here 1.02 seconds, is equal to distance traveled by echo. These two we can cancel and then multiply 1531 to 1.02 2, 6, 10, 1, 2, 3, 0 means instead of being here, we'll move one more place to left, and 1 ones are 1, 1 3s are 3, 5 and 1, so 2, 6, 1, 6, 5, 1, 1, 2, so your S will come out as 1561.62 meter distance traveled by echo, right? So that's what we are getting, 1561.62. So since in 1.02 seconds, the actual time, okay, the sonar pulse or echo, the sonar pulse, in bracket if you want you can write echo, travels twice, okay, twice the distance between the submarine and the cliff, twice the distance between the, okay, between the submarine and the, not cliff, I think it is the seabed, underwater cliff, sorry, yes, cliff, and the cliff, because submarine travels underwater, right? So underwater submarine is here, then the cliff is in front or something like that, so this is correct, okay, a cliff. Therefore, distance between the submarine from the distance of the submarine from the cliff, according to the language of the text, distance. How far is the cliff? Okay, distance of the submarine from the cliff. Okay, from the cliff. Actual distance between this, that means between submarine and the cliff, will be S divided by 2. Right, so S divided by 2. So that way you will get your answer as actual distance traveled by the echo. That means going, hitting the cliff and coming back to submarine is twice. So that will be 1561.62 divided by 2 meter. So if you cancel, 2 ones are 2, 7s are 14, 8s are 16, 0 because 1 is less than 2, then 16 point, then 16, 2 ones are 2. So 780.81 meter is the distance between the submarine and the cliff. Or if they ask you in kilometer, then meters 1, 2, 3, so divided by 1000, 0.81 divided by 1000, then this meter will go away, kilometer will come in. 1, 2, 3 because of these 3 zeros, so the decimal will come to the left of 780, no more here, so this much kilometer means approximately, you can put your 0, 0.7. A third place is 0 means less than 5, so the second place will not change. So this is your answer in kilometer, or this is the answer in meter. Okay, one more numerical. I think we can complete it in this class itself. So let us see. Yeah. So next is question number 7 on page 186. Textbook question. So question number 7, page 186. A person has a hearing range from 20 hertz to 20,000 hertz. So here, as we read the question, here hertz means the frequency, so denoted by small v, v1 is equal to 20 hertz, that is fine. And another range is there from lower to higher frequency, so next one is 20 kilohertz. We know that we have to convert this to SI units, so 20 into 1000 hertz, because we know 1 kilohertz is equal to 1000 hertz. 1 kilohertz. So changing big to small, so multiply by this 1000, then we're going to get 20, then 1, 2, 3 zeros, 20,000 hertz. Now both in hertz, lower range and higher range, upper range, right? Upper limit rather. Range is from here to here, and lower limit, upper frequency, lower frequency, upper frequency are the given frequencies respectively. So you can write here are the given frequencies of the sound respectively. Okay, then next, as we read on, what is the typical wavelength? So since there are two range, lower wavelength, let's put lambda 1 question mark and lambda 2 question mark, are the wavelengths respectively, are their wavelengths respectively. Okay, then that speed of the sound is given, which is v is equal to 344 meter per second. This is the speed of this type of sound, speed of the sound type that is mentioned in the question. So I think with this we can calculate the question is asking us these two wavelength corresponding to lower frequency and wavelength corresponding to higher frequency. Two answers will come out. So what are their wavelengths? So we know, it is quite simple, I think. Basic formula for one is there, that speed, since we know speed is equal to frequency lambda into sound wavelength into frequency, sorry. So since they were asked to find out this one, first frequency v1 here, see, lambda 1, sorry, lambda 1, this will be v by capital V, the speed, by small v1, the frequency. So speed is 344 meter per second divided by v1, here 20 hertz, so we write here 20 hertz is equal to the first wavelength that the question is asking. Find the two wavelengths, lambda 1 and lambda 2. So just we can do our way, but I think this will be easier. Doing with 2, then it will become 10, right? 2 1s are 2 0. So same 2 number, 2 2s are 4 1 and 7s are 14. Now don't cancel anymore. This 10 is very easy to divide. Okay, but before that, just one minute before cancelling, let us deal with this one first. 344 by 20. Okay, then we know from our previous classes as well, this is okay, meter per second. Hence is simply reciprocal of second. 1 by second means second you bring up, then it will become second to the power minus 1. So like this or like this we can write. So here, hence in place of that, second to the power minus 1 is equal to, so this second to the power minus 1 gone, so 2 0, 2 1 0, 2 1s are 2, 2 7s are 14, 2 2. Divided by 10 means decimal move from here to between 7 and 2. So here, this one here, lambda 1 will be 17.2 meter, the first wavelength and the first answer. So similarly, I can just write here the second wavelength. Directly from here we can do now. Lambda 2 will be, this one sound speed will be same by second frequency V2. So here 344 meter per second, that is same for both cases. And second frequency here is, see, 20, I have wrapped out, but we know it is 20,000 1 2 3 hertz. Just like we did that, so we will not explain it because we know now hertz is the reciprocal of time, second. So 20,000 1 2 3, sorry, 1 2 3 hertz means second to the power minus 1, so these two cancel. Again with 2, 2 1s are 2, then we will get here 1 followed by 0, very easy to divide. 2 1, 2 7s are 2 2, so 1 2 3 4 0. So starting from here, 1 2 3, 1 2 3 to the left, and one more because 4 zeros are there. Decimal is here now. Then this one, meter. Second wavelength, upper wavelength is 0.172. First lower level wavelength 17.2 meter. Those are your two answers. So now I can give the test. Okay.